should we start? I guess so. Guys, are you guys good to start? Yep, okay. So I guess we'll start my attempt at explaining escaping containers and Linux privilege escalation. So let's see, start with the overview of this workshop. So I'll explain what containerization is, why we use containers, and just a bit of containerization versus virtualization. And then we'll get into challenges. We have two challenges. The first one is called socket. Escaping using socket, not that one. Forget about deep C. Yeah. Oh, the host is muted. Okay. Yeah, nothing, don't worry. It's my computer. So what's Linux containerization? Just a second, let me bring up my notes. Okay. Has anyone here never heard of Docker containers? One? No, that's fine. Two? Okay. Okay, so containerization is the packaging of software code with just the operating system, libraries, and dependencies required to run the application to create a single lightweight executable. So basically, if you think of it like this, if you've ever worked with a Python project, you have your requirement.txt, which contains all the requirements to run that software. And you can, if you've ever used a virtual machine, it's more like whenever you do pip install the requirements, it gets all installed in a local VNV file, a folder. And this the folder itself, the parent, think of it as a container. It contains all the packages required to run your Python program, apart from Python, which will be in your binary directory. But yeah, it's just packaging. So you have components, a container engine. This is the most important part, which is a software platform for creating portable, reproducible environments to develop and run applications. The bundled environment is called an image, and a running image is called a container. Okay, so any questions so far? So why do we use containers? We could always run our application on your computer locally without having to do any containerization, and basically we'll get slightly better performance than containers. So containers, as we said before, collect software components together and can avoid software dependency problems. So maybe if you've ever run into problems where your friend is running, say, let's see, he's running the software on his computer and it's working fine, and then he gave you his code base and you try to run it, but it's not working. Well, if you use containers, then that problem can be easily solved because you will both have the same exact image and you can both run the software. You can also run it on different OSs and architectures as long as Docker is installed. Docker is a container engine. There are others. Images can be very small and reduce the time to deploy a new application. It works well with cloud computing. That's just something where you will find a lot, where Docker is used a lot. Okay, so next thing. Well, so this is just a meme. If it works on your machine, then we will ship your machine because it's working on your machine. Especially with big software, you could have hundreds of dependencies, and sometimes things might not run. So you need Docker or some sort of packaging system to ensure that your builds are reproducible. And this is just a meme to make fun of that. Okay, next thing was virtualization versus containerization. As you can see on the left-hand side, you have containerization. And on the right-hand side, you have virtualization. And if you're wondering what the difference between the short story is that containers are much lighter weight, really light, and they're much smaller. They're easier to deploy, and they're less secure than virtual machines. But they're still very secure, but not as secure as virtual machines. The long story is that to achieve this security and lightweight with Docker or containers. So containers use a technology called namespaces, or a feature, to provide isolated workspace. These isolated workspace, we call them containers. When you run a container, the container engine creates a set of namespaces for that container. And if you're wondering what namespaces are, they're things that a container can see. I will get more into this in a bit. We'll see why they're important. So namespaces provide a layer of isolation. Each aspect of a container runs in separate namespace, and its access is limited to that namespace. So, for example, if you have a container, the operating system, the host operating system will say, here are directories that you can see. Here's the CPU resources that you can see, memory, and this is all isolated. From the container point of view, it's as if it's running its own operating system. Sorry, it's as if it's running, it's the host. It doesn't know that it's, well, actually, you can find out whether it's running in a container or not, but from the operating system perspective, it thinks that it has all the resources. So namespaces flags, some of the namespaces that you might come across are C groups, IPC, so inter-process communication, network, mount, which you probably used, time, user, and PID. Okay, does anyone know how containerization work on Windows? If the host operating system is Windows? No, but how, like, sorry, I forgot to mention. So, or I hinted at it in the previous slide where I said that containers use a technology called namespaces, and namespaces is only available on Linux. So it requires the Linux kernel. No. On Windows, so whenever you install Docker, it ships with Linux kernel. Yeah, that's how they do it. Okay, so next slide. Yeah, so I mean, so you know how we said containers can have their own OS. So if we go back to that slide, they share the same kernel with the host operating system, but they run their own OS. Whereas if it was a virtual machine, you have your own kernel, and then the hypervisor translates syscalls, for each operating system. I think that's how it works. But if we go back to this, so if you have a container, you can actually run another container inside of it, and another one inside of it, and another one inside of it, and so on. And part of this workshop, I was trying to have deploy containers, the challenges inside the container, and run it on the server, and I was having problems, a lot of problems. But basically, I would run a container, then I would run a container inside of it, and I would tell you to SSH into that container so that you can escape it, but you're still inside another container. You're not on the host machine. Unfortunately, due to time, I don't think I was unable to deploy it. So yeah, so today we will be running them on, that was a bad name, but today we'll be running them on on your computer. Yeah. So there was I had a joke about how who here likes Mario? Mario. Okay, so I'll ruin it. Sorry. So Mario is known to hate his wife, abuse her. He's aggressive. So Princess, damn it, I forgot her name. Peach, yeah. Well, she decided to leave Mario and marry Darth Vader. Sorry. Just a second. So Mario put Princess Peach in a container. And our mission is to so this was all supposed to be part of the challenge, and the flags were related to Princess and Mario, but anyway. But unfortunately we'll do it on we'll be running the programs on our own devices, so we can't have those flags. So the first one is called mounted socket escape. So to understand how, I don't have a graph, maybe I should. So whenever you're on Docker, you have Docker daemon and Docker client, and Docker client talks to Docker daemon via socket. And sometimes for some reason, as is with software, you have people who run Docker container and they expose a socket inside that container. So they'll be doing something like, oh yeah, they're already released. Oh, okay, just a second then. So it's called Docker Container Escape 1 and Docker Container. Let me just edit this slide. I need to add this command beforehand. If you can. You know what? I guess we can start. We can start the. Are you guys happy to start? Just the challenge? Okay, not as well. So I posted code, the code that I'm going to be using in on Discord, and I'll explain what I'm doing. So first, to actually so this challenge exploits the fact that someone ran Docker, a container, and they mounted the docker.socket inside the container. And if you don't have this, then it will not work. So we first need to run a Docker. So it will take, for you, it will take some time to install Docker itself and run it. But for me, because I already had the image, it's instant. And the reason that we were using Docker image, because this makes it easy. You don't have to install Docker on the container. So I just installed, sorry, I'm running a Docker image, and it has Docker inside it, Docker client. You can see, okay. So to find whether you have Docker daemon socket on the container, you simply run find name Docker socket and see if it's there. Sometimes it's not at this location, and you'll have to search for it somewhere else, or it could be called something different. There are other tools that will allow you to find the socket, but for now we have it. And if you get at least one result, then that means the socket is open. So if we do Docker images, it will show you the images available on the host machine, because this Docker client is communicating with the daemon host via the socket. And this is what I was working on before on this machine, on this VM. And you can see I had Docker and Docker rootless, Docker and Docker, and I had Ubuntu images, Docker images, blah, blah, blah. So now we know that we can actually communicate with the daemon, and we're actually also root. What we can do is, since we have access to the Docker daemon on the host, we can simply run a container and bind the home directory to the root directory. So we're running Ubuntu container, and we're binding the home directory to the root directory. We're running inside this container, we're running chroot home, and we want a bash terminal. If you simply hit enter, and if we go to this other terminal, if we go to cd home, no wait, oh, it's already cd home, and we do watch. Let's see what kind of files we have here. ls, you can see that we have these files. So if we go back to our container that we see, we chroot into it. If we go to cd again, home, ls, no wait, cd, just a second. Why is this not working?
Yeah, I think like control shift left. Can you make it the text video?
Oh yeah, sure. It is just confused. Why is this ls snap pwp id cd ls vagrant ubuntu? Oh, a little bit bigger. Yeah, this one. How about now? And if we press F11, should be bigger. So as you can see my Vagrant machine. Even though we're inside a container, and the only thing that we needed was have a socket, daemon socket be available on the container. Let's see, ls, cd, vagrant. What kind of files do I have? Oh wait, yeah. As you can see, my home directory was actually mounted at this location, and I did not know that for some reason. But as you can see, here we're inside a container. So we were at a container. We used the socket to communicate with the daemon host. And once we realized that we can communicate with it, we ran a container using the daemon host, and we mounted the home directory inside this container, and we have full access to it. We can, if we create a file here, mkdir, let's just say, what's today? Let's call it hacked escape. It should show up here, and as you can see, this is hacked escape. Do you guys have any questions, or yeah, so the commands are there. You should probably, if you have any questions about any of the commands, just let me know. If you don't know what this does, or you've never ran a Docker container before, I can explain it. So yeah. The other challenge is much harder. So if you can't do this challenge, it's probably a good time to start it now. It might look simple, but the whole idea was to have a socket open inside the container, daemon socket mounted, and if you have that, then you have full control of the host. That's basically it. That's the gist. I should probably take a break.